Here we have a couple of problems where we're trying to classify triangles by looking at their side lengths. And triangles can be equilateral, they could be isosceles. Remember, an equilateral triangle has all three sides the same. An isosceles triangle has two sides the same. Could be scalene with three different sides, could be a right triangle. So those are some of the types of triangles that we're going to try to classify these into. So the question here is, which classification applies to a triangle with sides 11, 11, and 20? Hopefully this pops right out at you. Two sides the same, we've got an isosceles triangle. So that's that one, isosceles. Let's look at another problem. This one says, Mark went for a mountain bike ride in a relatively flat wooded area. He rode for 10 kilometers in one direction, then he turned and pedaled 14 kilometers in another. Finally, he turned and rode 5 kilometers in yet another direction. Stopping, Mark took out a map and drew his path. And then there are two questions here. Could Mark be back at his starting point? Well, if he's going to be back at his starting point, it has to be a triangle because there are three legs here. So there's 10, there's 14, and then there's 5. So it's possible, maybe, although we have to test it yet, it could look something like that. And then the question is, could his path be a right triangle? And we can also test for that. Now there is a little trick for testing whether a set of side lengths could actually be a triangle. And the rule is this. Every side, if you look at the other two sides, this side can't be bigger than the other two added together. So it can't be greater than the sum of the other sides. Well, 10 is not greater than 5 plus 14. 14 is not greater than 10 plus 5. And 5 is definitely not greater than 10 plus 14, so that works. And then the other part of this is each side can't be less than the difference between these two. So 10 is not less than 14 minus 5. 14 minus 5 is 9. 10 is not less than 9. That works. 14 is not less than 10 minus 5. 5 is not less than 14 minus 10. So this passes. It can definitely be a triangle. So could Mark be back at a starting point? The answer is yes. Could his path be a right triangle? Well, that we can test using the Pythagorean theorem. A squared plus b squared equals c squared. So 5 squared plus 10 squared, does that equal 14 squared? Well, 5 squared is 25, 10 squared is 100, and 14 squared, I think that's 196. Yes. Well, 125 does not equal 196. So the answer to this question, could this be a right triangle? No.